Hello everyone, I'm Soumitra and today I will be demonstrating an experiment that I have created in SAS Enterprise Miner. And in this demonstration, we will be looking at finding a solution for real-world data mining problem. So let's get started. As you can see, the dataset that I've taken is called car fuel consumption, which is available on Kaggle. And in this dataset, we will be determining the consumption of the fuel of a car depending on these independent variables. So going back to our SAS Enterprise Miner, as you can see, I have already created a model which I will be going through quickly. So I have already imported my data set, and the Stat Explorer option which I have used gives us a visualization of our data set. And after executing and looking at the results and going back to the results, as you can see, we have got three different plots and one plot which is called variable plot. So this plot is basically telling us the relation between different independent variables with the dependent variable, which is the consume. But if we go back and we look at our variables in our data set, we will be quickly getting an idea of what exactly our data set independent variables are. So as you can see, our independent variable AC, whether the AC was on or off, the consumption of our consumption of the fuel of a car, which is our target variable and is of interval type, and AC was of binary type. Distance, which is of interval type, the distance, which means the distance that our car has traveled, whether there was rain or not, the gas type, which is binary type, and what was the temperature inside the car, temperature outside the car. So these are our independent variables. And as you can see, if we go back to the Stat Explorer option and we look at if there are any missing values in our data set that we would in future need to be cleaned. So going back to the results of Stat Explorer, we will be able to see that if we go to the output and we look here, there are 12 missing values in our data set in the temperature inside column. So we will be cleaning these 12 missing values, which is my first concept. So the input that I have used is used for cleaning of our data set. And as you can see that the input option, if we look at the results of our input, and we will be looking at that our 12 missing values are getting replaced by the mean of all the other values of all the other data in our data set. So here is the result of our input option, and as you can see, it has identified the 12 missing values. And if we go further, we'll be able to see that the data partition method, in which I have used 40% of our data for training purpose, 30% of our data for validation purpose, and 30% of our data for test purpose. And going further, I've used control point. The control point is used for the flow of our data into different models. And the second concept that I've used is decision tree. So in decision tree, what I have done is for limiting the pruning, limiting the overfitting, I've used the pruning. So pruning means that I have actually limited the classification of our tree into different depths, and the maximum depth that our tree can have, I have kept it to 10, and the maximum branches can be 2. So, and the best possible spread is going to get determined by the entropy. So if we go to the decision tree and we look at the results of our decision tree, we'll be able to see the tree that has been formed from our data set. And looking at the results of the decision tree, we will be able to, so here is our decision here is our decision tree, and as you can see, the tree that has been formed, and you can see the distance is getting used for the splitting purpose. And if you see here, if the distance is lesser than 3.55, you can see the fuel that is getting consumed is 7.366 gallon, and if the distance is greater than 3.55, the fuel that is getting consumed is around 4.77 gallons. So this is our decision tree. And going back to our model, the third concept that I have used is neural network. So neural network is a highly complex algorithm, and if we look at the results So in the neural network, the optimization method that I've used is backpropagation. So backpropagation is an algorithm where we apply different weights to our input data to find the best possible weight, and this is basically a feed forward network, and by this we determine the best possible weights for our data, and for the maximum iteration that our backpropagation method can have is 50, and the maximum time that I have allotted the backpropagation method is 10 minutes. So we're looking at the neural network's results, and we'll be able to see that there are different ways that our neural network has applied to our input data, and uh, so here, as you can see, this is our output of our neural network, and in this graph we can see that in here it is the 46th iteration where our neural network has found the best possible weight for our data set, and in the output we will be able to see that there are these are the weights, the random weights that our neural network method has applied to our data set. And the fourth concept that I've used is ensemble. So ensemble is a method in which we have combined two or more different weak models to form a stronger one model. And if you can see here, I've used all these three models to compare, and I have compared all the three models and also use a control point for the flow of data. And if we go here and look at the model comparison and evaluate the result of all the three models, and if we look at the results of our model comparison, we will be able to see which model has performed the best and which is the most efficient model within all the three. So let us see the results of our model, and if we go to the output, and here at the test data set, if we look at the average squared error, we can see that a neural network is the least efficient, and ensemble is the one model which has performed the best, and so we can conclude that ensemble model is performing the best for our data set. So this was my demonstration for SAS Enterprise Miner. Hope you all have a good day. Thank you.